In the previous weeks, we started with requirements. We created an SRS, we looked at user stories, we created the UI for these stories. Now, before we start development, we have to create the design of the system. What is the design? Design is a way of organizing the code that you will implement and providing a structure to the software system. How do we go about doing this? And what should we get after such a design process? Is it the code directly or is it some intermediate representation? What is the outcome of this design process? We will look at all these points in this week. So, what is the outcome of the design process? Broadly speaking, there are 4 outcomes. Firstly, we have the components of the different aspects of the design. Then there are the interfaces between the components. Then we have the data structures which store the data, and we have the algorithms which run on this data in order to produce the desired result. So, what are each of these? So, the components are what you might understand as modules of the solution. So, it is a collection of functions and data shared by these functions. So, the idea behind these modules is that each module should accomplish some well defined task, and the modules all work together to provide the functionality of the system. What are interfaces? Interfaces are nothing but the way in which components or modules communicate with each other. So, they define the manner in which data is exchanged between these components. The need here is that the sending component and the receiving component need to be able to understand how to interpret the data that is exchanged. So, that is called an interface. We will learn more about this as we go along. Then there are the data structures for individual components, right. I mean, you are all familiar with arrays and lists and trees and so on. So, how different data is implemented or stored is captured by the data structures that we use within the modules. And finally, there is the algorithm which actually runs on the data in order to produce the desired effect. So, components and interfaces are the key elements in a high level software design. This high level design is known as the software architecture. Once the architecture is decided, then we can move into lower level design details, as we will see in the coming videos. The focus of this week is to understand how we can represent this high level design of the system. In later weeks, we will look at essential practices and guidelines for creating effective software architectures. There are many different types of notations that are used to represent a high level design. The most popular one is called UML, or Unified Modeling Language. UML can be used to describe different views of the system, a user's view, a functionality view, a messages view, and so on. So, we will look at UML diagrams in detail in the upcoming videos.
So now let's look at the example of the Amazon seller portal, right? We have looked at this example in the past weeks as well. So how did we start building this system? So we started with the requirements which we collected from the clients, from the stakeholders, through the SRS, through user stories, and we created different user stories which describe different functionalities of this system. For example, we have a view inventory user story which enables a seller to view his or her inventory, and we have another feature for tracking customer feedback. So we collected several or created several of these user stories, and now we have to implement. And now that we have these different requirements or user stories, now we identify common functionalities and we then group them together into tasks. We saw this in the software project management week, right? And these tasks can form the components of the system. For example, we identified components like the catalog management component, the inventory management, payment tracking, and so on. So now how can these broad or these components be represented using UML diagrams and other notations is the focus of this week.
So here is a reflection spot. What is good software design? Let us say you have come up with the main components and interfaces of your system. Now how do you know that this system is good? Take a moment to think about this. There are many characteristics of a good software design. One of them is called correctness. That is, does it correctly implement the functionality of the system? As we saw earlier, the main way to do this is to ensure that requirements are correctly captured first. Ensure that the requirements are not ambiguous, they do not conflict with each other, and they are complete. This can ensure that all the functionalities are correctly captured in the design. Another characteristic of good software design is efficiency. Efficiency means that we want to ensure that the resources, that is the time and the space and the cost, are managed well. For example, when you are trying to choose the development framework for an application, you have to decide whether this is the correct one. That depends upon the application, whether you are building a client server application or whether you are building a mission critical system and so on. For example, if you are building an embedded system, then it has to work under limited memory sizes. So does the design ensure that these considerations are met? So this is another important criterion that characterizes good software design. One more important characteristic is maintainability. That is it easy to maintain the code or change the code or make some changes? As we saw earlier, requirements can change either during the process of software design itself or later. So new requests can come even after the product is released. Sometimes we want to upgrade the product, let us say. So in all these cases, we do not want to redesign the entire software from scratch. So it is important to ensure that the design is maintainable. What does that mean? That means that we can make these changes in the existing design and the existing code itself without too much effort. And finally, one more important characteristic of good software design is understandability. What do we mean by understandability and why is it important? Understandability simply means that everyone in the team should be able to follow the design. Why is it important? Unless everybody can understand the design, they will not be able to implement the system, which can in turn lead to bugs and higher development as well as maintenance costs. So apart from correctness, understandability is also an important issue to consider while judging a design. In this week, we will look at certain characteristics which make the design more understandable, hence in turn leading to creation of better designs.